They tell us the universe is 13.8 billion years old, as if numbers could ever carry the weight of what that means. We repeat the figure like children reciting a date from a textbook, pretending we understand it, pretending it is just another fact to file away. But time on this scale is not a number. It is a chasm, a canyon carved through the soul of reality, so vast that human history clings to one tiny ledge in its wall. And here, balanced on this fragile moment, we dare to believe we are the first to arrive, the first to open our eyes in the dark and ask who else might be out there. We cling to this belief the way a castaway clings to driftwood, because the alternative is more frightening than the emptiness itself. Yet if the universe is so old, why should we be? Why should life have waited for us? For this late-coming species on a pale blue orbiting a mediocre star in an unremarkable arm of a spiral galaxy. Our own planet is barely 4.5 billion years old. In cosmic terms, we are newborns in a room full of ancient voices. And if life can rise here, on a world born from chaos, soaked in storms and shadows, could it not have risen somewhere else earlier? Not thousands or millions of years earlier, but billions? Imagine a civilization that began not yesterday in cosmic terms, not last week, but in the very dawn of time, when the first galaxies were just weaving their arms together, when the stars were younger, hotter, more eager to burn themselves into light. Imagine they had 10 billion years to think, to build, to learn. 10 billion years to understand physics in ways we still mistake for magic. What would they see when they looked at us? Would they even recognize us as alive? Would we, to them, be creatures or patterns, individuals, or just a fleeting turbulence in the cosmic tide? We search for radio signals, as if an ancient mind would still use the technology of our grandparents. We scan for chemical traces in exoplanet atmospheres, as if beings that old would breathe oxygen, or breathe at all. What arrogance, to assume they would still be made of matter. If time is a ladder, they have climbed it beyond the reach of our eyes, beyond the rung where stars are born and die. For them, the universe is not a home. It is clay, soft and yielding, to be shaped as they wish. The rules we call fundamental may be, to them, just options in a menu they learned to edit long before we learned to write. But what if they have not left? What if, instead of moving away from us into unreachable abstraction, they are here, woven into the structure of things, not as visitors, but as custodians? And what if they are watching, not through ships drifting past our telescopes, but through the quiet bending of forces, the faint reshaping of probabilities, the subtle pressure of history's path being nudged in ways we cannot measure? It is tempting to imagine such watchers as benevolent, like elders tending to a fragile child. But time corrodes empathy as easily as it polishes wisdom. 10 billion years is long enough to forget what it was like to be small. Perhaps they do not watch us to protect us. Perhaps they watch as an astronomer watches a comet, noting its path, calculating when it will fade from view. Perhaps we are less their concern than their curiosity. Every so often, in our telescopes and detectors, we see something we cannot explain. A strange dimming of a star. A patch of cosmic microwave background colder than models predict. Gamma bursts from no visible source. We tell ourselves these are natural events. We invent names for them, file them away, move on. But in the back of the mind, the question lingers. What if these are not accidents of nature? What if they're the movements of something that learned, long ago, to speak in the language of physics instead of sound? A civilization that leaves no monuments of stone, no metal ruins, only alterations in the fabric of reality itself. Light is slow, even when it races. The glow from the farthest galaxies we see tonight set out when the Earth was not yet dust. If they're watching us now, they may see not who we are, but who we were, our ancestors, our beginnings. To them, we are a story unfolding in slow motion, a narrative they can study without ever being noticed. But what if they can do more than watch? What if they can edit? What if the difference between an ice age and an age of fire is, to them, a decision as small as pressing a key? The structure of the universe is not a perfect accident. The constants of nature, gravity's pull, the charge of the electron, the speed of light, are balanced on a knife's edge, tuned so precisely that life can exist at all. We call it the fine-tuning problem, as though giving it a name makes it less unsettling. But in the hands of a civilization 10 billion years older, fine-tuning would not be a problem. It would be a tool. What if the balance we see is not the universe's original state, but one adjusted, sculpted, and rebalanced for reasons we will never guess? And what if our existence is not incidental, but intended? When you look up at the night sky, you are not just seeing stars. You are seeing a map, a canvas on which someone, perhaps, has already drawn. The constellations are ours, but the positions of the stars are not. They're set by gravity, by time, and maybe by choice. A choice made before our kind had language, before the first cell on Earth divided. We like to think we are explorers, the first to set sail into the cosmic ocean. But what if the ocean was charted long before we left shore? What if every nebula we marvel at is the monument of an older hand? What if the silence we hear when we listen for life is not the absence of voices, but the quiet of something holding its breath? And what if the first sound we ever hear from them will also be the last? And what of us? We are restless. We invent. We break limits, and then we break the new ones we've made. But in the presence of something so old, so patient, our restlessness might be nothing more than a curiosity, a flicker of movement in the corner of their vision. Would they intervene if we threatened to harm ourselves? Or would they let us vanish, as they have surely watched others vanish before? How many civilizations have burned and gone cold in their sight, their final moments unmarked by any act of mercy? There's an unease in asking these questions, because the moment you admit they might be watching, you must also admit they might have reasons not to be seen. And any being that can remain unseen for 10 billion years is not hiding by accident. That kind of silence is not born of shyness. It is born of mastery. We stand, without knowing it, at the edge of a vast and ancient stage. The curtain is the night sky. The lights are the stars. And beyond them, in the wings, something waits. Watching not for our applause, but for the moment the play becomes interesting. And perhaps, in ways we cannot yet understand, it already has. They say history leaves marks, stone ruins, buried artifacts, bones that whisper of the people who carried them. But in the cosmos, history does not leave ruins the way we imagine. It leaves distortions. It leaves shadows. And the most ancient civilizations, those who lived and died billions of years before our species could even dream, may have left their fingerprints not in dust or debris, but in the very shape of the universe. We think of the past as something you can dig for, uncover, catalog. Archaeologists search for broken pottery, shattered monuments, written words preserved in clay. But cosmic archaeology is different. You cannot unearth the past. You must look outward and backward and sideways all at once. You must search not for artifacts, but for patterns, subtle anomalies in the dance of galaxies, faint irregularities in the echo of the Big Bang, unnatural alignments in the starlight that reaches us. The past is not buried in the ground. It is buried in the sky. When we map the cosmic microwave background, the faint radiation left over from the universe's infancy, we see a near-uniform glow. It is the first light the cosmos ever allowed to escape, frozen in place for over 13 billion years. But it is not perfectly smooth. There are patches where the temperature is just a fraction of a degree lower than it should be. One such region is called the cold spot, and its size is staggering, billions of light years across. Our models strain to explain it. Some say it's just a statistical fluke, the aftershock of cosmic inflation. Others whisper that it may be a scar, a shadow not of nature's making, but of an intervention. Imagine, for a moment, a civilization that has mastered not only the stars around them, but the initial conditions of reality itself. A culture so far ahead of us that they can nudge the energy fields of the newborn universe as easily as we sculpt clay. Could the cold spot be the shadow of their architecture? A place where energy was drained, space thinned, light subtly redirected for purposes we can't guess. We talk of megastructures, Dyson spheres, swarms of satellites that drink the light of a star to power unimaginable machines. But why stop at stars? Why not build on the scale of galaxies, bending them into shapes that obey not nature, but design? A spiral galaxy could be twisted tighter to store angular momentum. An elliptical one could be stripped of its gas to halt star birth, turning it into a cold vault of data frozen in the dark. These would not look like monuments in the way we expect. They would look like astrophysics, until you notice the patterns repeating in different corners of the sky. And patterns are what haunt astronomers. Unnatural distributions of galaxy spin directions. Quasar light that dims and brightens in strange synchrony across distances too vast for any natural cause. Clusters of stars whose ages are mismatched with the chemical story of their birth. Each anomaly alone can be explained away. Measurement error, coincidence, unknown physics. But together, they feel less like random accidents and more like brushstrokes in a painting too large to see up close. Light, after all, is the perfect messenger for such civilizations. It is the one thing that crosses the abyss between stars and galaxies without aging beyond use. But to use light as a signal across billions of years, you cannot rely on codes as we know them. You must alter the light's source, change the stars themselves, adjust the timing of a supernova, dim one star in a cluster while brightening another, creating a pattern that only a patient, watchful eye could see. For us, the night sky is a scattering of diamonds. For them, it could be a script written in stellar fire. Yet the most haunting possibility is not in what they might write, but in what they might erase. A star can be hidden. A planet can be stripped of its atmosphere until no telescope will ever know it bore life. Even entire regions of the cosmos could be cloaked behind gravitational distortions, bent so that their light never reaches us. We would not know what we are missing, only that the universe seems emptier than it should. And perhaps that emptiness is not nature's doing. Perhaps it is theirs. The Fermi paradox asks, where is everybody? But what if everybody has been here all along, simply too old to want to be found? What if their traces are all around us, but we have trained ourselves not to see them? Dismissing anomalies as noise, assuming patterns are coincidences, refusing to imagine that someone could alter reality on a scale that dwarfs our own existence. We like to believe we are open-minded explorers. In truth, we are careful prisoners of our own definitions. Sometimes, late at night, astronomers find themselves staring at data that won't behave. Light curves that bend when they shouldn't. Signals that almost seem artificial. And in that moment, they face a choice. Publish and invite ridicule, or file it away and tell themselves they were mistaken. This is the quiet censorship of the cosmos, not imposed by some alien overlord, but by our own fear of appearing foolish. The watchers, if they exist, could not have asked for a better filter. We imagine that if we found evidence of them, true evidence, we would know instantly. We would feel the shiver of revelation. But the truth is, we could already be holding it in our hands, staring straight at it, and not realize what it is. Because it wouldn't look like the saucers and signals of our science fiction. It would look like the universe itself, only slightly wrong. A star where there shouldn't be one. A shadow that refuses to move. A region of sky that is too quiet, too smooth, as though someone has swept away the noise. And what would that mean for us? To know that the universe we study is not entirely natural, that some fraction of it is curated, managed, perhaps even cultivated? Will we feel awe or betrayal? Would it make us feel less alone or more trapped? The shadows cast by time are long. They stretch from the first moments after the Big Bang to the photons entering our telescopes tonight. And in those shadows, there may be more than absence. There may be memory. Memory of acts carried out before our kind existed. Memory of choices made by minds that saw the same sky and decided to change it. Minds that understood time not as a river to be carried by, but as a sea to be navigated. And somewhere, hidden in the data, is the possibility we have never dared to say aloud, that these changes were not just experiments, but warnings. That the patterns we see are not random marks of creation, but signposts for those who come later. Signposts we are only just beginning to notice. Because maybe they are not gone. Maybe they never were. Maybe what we call the natural universe is simply their shadow, and we, without knowing it, have been living inside it all along. Mathematics is supposed to be the purest thing we have, untouched by the mess of human perception, immune to the biases that twist every other form of understanding. Numbers do not care who reads them. Equations do not change their truth because we believe or disbelieve. In this sense, mathematics is our one fragile bridge to the universe's deeper order. But what if hidden in that order, there are shapes that should not be there? What if, among the pristine structures of physics, there are fingerprints? Physicists like to say that nature is written in the language of mathematics. The falling of an apple, the orbit of a moon, the arc of light bent by a galaxy's gravity, all of it can be described, often with terrifying precision, by formulas. To a mind that has lived for 10 billion years, those formulas would be no mystery. They would be tools, and tools can be sharpened, altered, or used to carve designs invisible to the untrained eye. Consider the constants: the speed of light, the gravitational constant, the ratio of the electron's mass to the protons. These are not numbers you can tweak without consequence. Shift them slightly and the universe collapses into sterility. Stars cannot form. Atoms cannot bind. Life becomes impossible. And yet, in all our measurements, these constants are exact to many decimal places. So exact that they have the eerie stillness of something maintained. We call it fine-tuning, and most scientists stop there. But what if fine-tuning is not the product of cosmic luck? What if it is deliberate calibration, a maintenance schedule carried out on a scale of eons? In our own tiny history, we have begun to learn how to manipulate constants in controlled environments. We create artificial magnetic fields to steer particles. We adjust temperatures to manipulate superconductivity. Now, imagine a civilization for whom the constants themselves are no longer constant, for whom the gravitational strength of a region can be dialed up or down, light speed adjusted for a specific corridor of space, quantum fluctuations dampened or amplified like the gain on a radio. They would not simply live in the universe. They would live in the equations. This is where mathematics becomes haunted. There are patterns in the cosmic background radiation, in the clustering of galaxies, in the distribution of dark matter, that seem to have echoes, symmetries that are not predicted by our current models. They are faint, statistical whispers. Most physicists explain them away as coincidence. But coincidence, repeated with precision, becomes something else. Repetition is not nature's favorite language. It is the language of intent. Take the golden ratio, phi, which appears in the spirals of galaxies just as it does in seashells and hurricanes. Its recurrence is not, by itself, evidence of manipulation. Nature is fond of efficiency, and phi is efficient. But when we begin to find exact multiples or harmonics of phi embedded in unrelated cosmic phenomena, we start to wonder. Why does a cluster of quasars align to within a tolerance tighter than random chance would allow? Why do the large-scale filaments of dark matter form angles suspiciously close to perfect thirds and fourths? Nature tolerates imperfection. Engineers do not. This is not to say that every neat pattern in the sky is the mark of an ancient architect. Randomness is still vast. But in certain places, the probabilities become so strained, so unlikely, that we must ask ourselves, are we glimpsing artifacts of thought? Not thought as we know it, bounded by language and neurons, but thought encoded directly into the scaffolding of space and time. If you wanted to leave a message that would last longer than any star, you would not write it on stone or metal. You would write it into the equations that govern the cosmos. You would tweak the gravitational constant just enough that billions of years later, a curious young civilization would find it strange. You would align galaxies so that from a certain vantage point, they formed an unmistakable shape, one that only emerges once that civilization has mapped the sky in its entirety. You would bury your words in the mathematics itself, so that to understand them would require first understanding reality. And maybe that is the point. If the Watchers exist, perhaps their messages are not meant for everyone. They may not even be meant for us. They may be addressed to peers. Other ancient civilizations spread across the dark, each capable of recognizing the same symmetries, reading the same equations, following the same breadcrumbs of probability. We might be eavesdropping on a conversation so slow, so deliberate, that a single exchange takes millions of years. There is another possibility. These patterns we find, the golden spirals, the alignments, the harmonics, may not be messages at all. They may be fingerprints left by tools we cannot see. Just as a sculptor's chisel leaves marks in marble, their manipulation of physical law may leave side effects, minor distortions that persist in the data. To us, they are anomalies. To them, they are background noise, the ghostly remnants of work long finished. The question then becomes, are we meant to find them, or are we only seeing what's slipped through the cracks? If the Watchers can alter constants and manipulate structures on a galactic scale, they can surely erase their own footprints, which means the ones we see are either unimportant or bait. A lure for civilizations like ours, drawing us toward questions that lead to places we may not survive. And yet, we cannot help but look. We are a species addicted to patterns, to pulling meaning from noise, to making sense even where there is none. Perhaps this is why we will keep looking, keep measuring, keep chasing the mathematics of ghosts. Because deep down, we want to believe that the universe is not indifferent, that its beauty is not just the byproduct of chaos, but the deliberate work of something that came before us. If that is true, then every formula we write, every equation we solve, is not discovery, it is archaeology. We are not inventing mathematics. We are brushing dust from carvings left for us in the stone of space-time. And maybe, one day, we will clear away enough dust to see the whole shape. And then, we will finally know whether the ghosts and the numbers are real. When we look at the sky tonight, we are seeing the universe in its middle age. The stars we know, our sun, the bright giants in Orion, the red embers on the horizon, are products of a cosmos already rich in heavy elements, already recycled through generations of stellar birth and death. But in the beginning, when stars were young, the light was different. It was harder, bluer, more intense. And life, if it emerged in that time, would have been forged in a furnace unlike anything we can imagine. The first stars formed just a few 100 million years after the Big Bang. They were immense, hundreds of times the mass of the sun, burning their fuel in a few million years before exploding in supernovae so violent they seeded entire regions with the raw materials for planets and, eventually, biology. These stars, called population 3 stars, no longer exist. They lived fast and died young, leaving behind only whispers in the spectra of distant galaxies and the enrichment of the cosmic medium. But what if those first suns were not only the engines of chemistry, but the beacons of civilization? We imagine life taking billions of years to arise, because that is what happened here. But perhaps elsewhere, under hotter, denser skies, complexity bloomed in centuries rather than eons. If intelligence arose then, in the first billion years of cosmic history, it would now be older than our planet. It would have watched galaxies collide, black holes grow fat on the hearts of suns, clusters drift apart into the expanding dark. It would have had time not only to master its surroundings, but to reshape them. What does it mean to be that old? To have seen the universe when it was small enough that a single civilization could, in principle, cross it in their lifetime? We think of the cosmos as infinite, but in those days, horizons were nearer. Distances, though still unfathomable to us, were less forbidding. An ancient people could have mapped much of what existed then, mapped it, and perhaps claimed it. And if they claimed it, they might have left marks we could still find. Not monuments of stone or steel, but modifications in the very arrangement of matter, adjusting the formation of star clusters so that their light carried signals, redirecting the collapse of gas clouds so they birthed systems stable for trillions of years, planting the seeds of artificial worlds long before any natural ones had cooled enough for life. Astronomers today study the earliest galaxies by capturing their light in deep field images, exposures that last for days, collecting photons that have traveled for more than 13 billion years. In those dim smudges, we see the universe as it was when it was less than a tenth of its current age. The shapes are primitive, chaotic, half-formed. But every now and then, we find structures too orderly for their time. Massive clusters already assembled, galaxies with surprising symmetry, alignments that defy the turbulence we expect from such a young cosmos. The explanations are always natural, some quirk of dark matter, some early surge of star formation. But could they be more? Could they be the last visible fingerprints of those who saw the first light and chose to shape it? If such beings existed, their perspective would be unimaginable. For them, time would not be an arrow, but a landscape. Their history would not be a chain of events, but an ocean they could swim through at will. 10 billion years to learn would give them not only mastery over matter, but perhaps mastery over causality itself. The rise and fall of stars might become as trivial to them as the changing seasons are to us. They could sculpt stellar lifespans, trigger or delay supernovae, feed or starve black holes as one might tend a garden. And if they could tend a cosmic garden, they could prune it as well. If the early universe birthed many civilizations, perhaps some did not survive, not because they failed, but because they were removed. When stars were young, resources were abundant, but so too was competition. We think of life as rare, but in that fertile dawn, it might have been plentiful enough for predation. Entire species, entire empires, could have been erased before they ever had the chance to become old. In that light, the silence we experience today takes on a different shade. Maybe the early abundance led to an early culling. The survivors would be the ones who learned to hide, to mask their presence, to fold themselves into the background noise of physics. And if those survivors still exist, they're not the kind to announce themselves to curious newcomers. The most chilling thought is that they could have shaped the universe in ways that guarantee their dominance forever. Imagine adjusting the initial density fluctuations of the cosmos so that galaxies form only in certain regions, leaving vast deserts of empty space in between. Any younger civilization born in those deserts would find the nearest neighbors impossibly far away. Expansion would be a dead dream before it began. And in the fertile regions, perhaps the elders still tend the flame, watching the rise of any species that might threaten their long dominion. The traces of such shaping would be faint, nearly indistinguishable from the work of nature. Nearly. We might find them in the statistical distribution of galaxy clusters, in the curious absence of certain mass ranges of black holes. In a peculiar way, some regions of the universe seem richer in heavy elements than they have any right to be so early. We like to imagine that if we encountered an ancient civilization, we could learn from them, benefit from their wisdom. But wisdom is not the same as kindness. A people forged in the fierce light of the first stars might see us as little more than noise in their grand design. We would be latecomers to a game whose rules were written before our sun was born. When stars were young, the universe was smaller, brighter, hungrier. If intelligence emerged then, it has had aeons to grow beyond anything we can fathom. And if it still exists, somewhere in the deep dark, it is not waiting for us to find it. It is watching to see what we do next. We're used to thinking of surveillance in human terms. Cameras on street corners, satellites in orbit, drones tracing shadows over battlefields. But these are crude instruments, temporary and fragile. They rust, they fail, they depend on energy and infrastructure. The watchers we imagine, those with a 10 billion year head start, would have no need for such brittle eyes. Their architecture of surveillance would be built into the universe itself. We search the sky for anomalies and imagine that is enough, but a truly ancient intelligence would not be so clumsy as to leave its presence in anything we could find by accident. They would not send probes, not in the way we understand them. They would not beam messages across the void in the faint hope we were listening. They would not need to. The same laws of physics that bind our world together would be their instruments, their network, their code. Consider the stars themselves. A civilization with mastery over stellar engineering could turn suns into sensors, their light modulated to carry information across intergalactic distances. A star's corona could be seeded with structures invisible to us, each altering the spectral signature in patterns we mistake for natural variation. The dimming of light from distant suns, events we now ascribe to planets passing in front, could be deliberate, timed sequences, each eclipse a syllable in a message, or a tick in a clock measuring our progress. Or perhaps the watchers use black holes. To us, these are mysteries, places where light itself cannot escape. But to them, an event horizon could be a lens, a gate, a perfect recorder of information. Matter falling into a black hole leaves a unique signature in gravitational waves, ripples in space-time that can cross the cosmos without being absorbed or scattered. A network of manipulated black holes could form a surveillance grid as vast as the universe itself, able to detect any disturbance in the fabric of reality. Even a void could serve them. Space is not empty. It hums with virtual particles flickering in and out of existence, with quantum fluctuations that stitch the cosmos together. An ancient mind could learn to read those fluctuations as easily as we read words on a page. Every movement, every burst of energy, every shift in gravity would leave a mark in the vacuum. To watch us, they would not need to be near us. They would only need to be tuned to the whispers in the background of reality. And what a time! We imagine observation as something that happens in the present, but what if their surveillance spans the timeline itself? If they can manipulate the flow of time locally, they could rewind and replay events at will, studying us not as a live feed, but as an archive. Every choice we have made could be replayed, slowed, dissected. Our history would not be a mystery to them. It would be a library they could browse. If this sounds impossible, consider that we are already, in our primitive way, building archives that approach such a scale. We have begun to map every star in our galaxy, every asteroid, every comet, tracking their paths so precisely we can predict their position centuries from now. We are turning the sky into a data set. Now extend that process by 10 billion years and imagine the completeness of their records. Not just positions of stars, but the orbits of molecules. Not just events, but the probability of events. Not just what happened, but what would have happened if history had been another way. This is not surveillance as we understand it. It is ownership of knowledge. To watch in this way is to know without needing to ask. It is to remove chance from the equation of awareness. In such a system, the watchers would never be surprised. But the architecture of their surveillance would not be static. It would evolve, just as living systems evolve. Stars die, galaxies drift apart, black holes merge. Their network would adapt to these changes, reconfiguring itself in ways that would be invisible to us because they would happen on timescales we cannot feel. What seems to us like the natural life cycle of the cosmos could be, to them, the scheduled maintenance of their instruments. The most unnerving thought is that this architecture might not only observe, it might influence. A network of stellar and gravitational sensors could just as easily act as a system of levers, subtly nudging the trajectories of worlds, the energy flows of stars, the expansion rate of space itself. Surveillance and control would be two sides of the same coin. To watch everything is to hold the capacity to change anything. And if that is true, then perhaps our history is already shaped by their gaze. Our survival may not be the result of luck or of our own ingenuity, but of decisions made far away and long ago. Catastrophes averted not by chance, but because it suited them for us to continue. Extinctions allowed to happen because they posed no threat to the pattern they are tending. We might not even be the focus of their attention, just one of countless threads they track, adjusting only when necessary. We are left with the question, why watch at all? What is the purpose of building a surveillance network that spans the universe and lasts for billions of years? The answers are unsettling in their simplicity. Curiosity, control, fear. Perhaps they watch because they fear what younger civilizations might become. Perhaps they watch because they are shepherds of a cosmic order we cannot yet see. Or perhaps they watch for the same reason we do, for the thrill of knowing, for the satisfaction of seeing a story unfold. We like to imagine that if such watchers existed, their gaze would be obvious to us. A beam of light across the stars, a ship descending from the clouds. But the architecture of surveillance they might build would not announce itself. It would be indistinguishable from the fabric of a universe. We could live our entire existence under that gaze and never feel its weight, until the day it turns its focus entirely upon us. And maybe that is the point. Maybe the only sign we will ever have that we are being watched is not in what we see, but in what we don't. In the anomalies that never happen, in the disasters that never come, in the quiet persistence of a world that, against all odds, continues to spin. We have been listening for a long time. Not as long as the universe has existed, not even as long as our species has walked upright, but long enough to know what silence feels like. Our radio telescopes sweep the sky, their great dishes turned toward distant suns, hungry for the faintest trace of something artificial. Decades pass. Generations of astronomers retire and die. The signals we find are all the same. The whispers of quasars, the hiss of cosmic background radiation, the murmur of hydrogen clouds adrift between stars. Nature talking to itself, and yet sometimes it feels like the silence is too perfect. We imagine that in a cosmos alive with intelligence, the airwaves should be crowded, that ancient civilizations would leave their fingerprints in obvious, noisy ways. Messages beaming across the void, transmissions like cosmic graffiti sprayed on the walls of space. But what if the silence is not an absence? What if it is an act? What if it is curated? The idea is unsettling in its simplicity, that the quiet we hear is the product of control, not emptiness. If a civilization has learned to manipulate light, gravity, and energy on scales we cannot yet grasp, then filtering signals, editing what younger species can detect, will be trivial. They would not have to block every frequency, every wavelength. They would only have to shape what reaches us. The rest could remain hidden in forms of communication we do not even recognize as communication. Perhaps they speak in neutrinos, those ghost particles that pass through entire planets without slowing. Perhaps their language is written in gravitational waves, which we have only just learned to detect. Or perhaps they speak in a medium we have no name for yet, a layer of physics beyond our instruments, as far beyond us as radio is beyond a caveman. In that case, the silence we hear is not silence at all. It is simply the absence of our ability to listen. But there is another possibility, and it is darker. The silence could be deliberate, not because we cannot hear, but because they do not want us to. Imagine a filter stretched across the entire observable universe, a kind of cosmic quarantine. Any signal that might reveal the presence of advanced civilizations is dampened, distorted, or erased before it can reach us. This would not require magic. It would only require a network of observers placed in strategic positions, star systems, black hole orbits, galactic halos, intercepting and managing information flow. To us, the sky would look untouched, but everything we see, every photon, would have been approved for release. The chilling part is that such a system would be indistinguishable from nature unless you already knew it was there. We would still believe we were free explorers in an open universe, when in fact we were moving through a curated exhibit. The galaxies we marvel at could be the parts of reality we are meant to see. The truly interesting places, the civilizations, the great works, the strange and dangerous regions, could be hidden behind masks of emptiness. And yet, there are moments when we almost sense the presence of something behind the quiet. A signal that appears and vanishes before it can be confirmed. A repeating burst of radio waves that seems too regular to be natural until we find a plausible natural explanation. Patterns that rise from the noise and then dissolve again, leaving us with nothing but the suspicion that we missed something important. These are the quiet between signals, not the spaces where nothing is happening, but the spaces where something is happening out of reach. In our own small way, we have already begun to do this ourselves. We censor our transmissions when they might reveal military secrets. We encrypt data to keep it from hostile eyes. We broadcast on narrow beams instead of open channels when we want privacy. It would be naive to think an intelligence millions or billions of years older would not do the same, especially if it had reasons to remain hidden. The question, then, is whether the quiet is meant to protect them from us or to protect us from them. Perhaps the sky is silent because the truth would be unbearable. Maybe they have seen what happens when younger species learn too much, too quickly. Maybe they have watched civilizations destroy themselves after glimpsing what lies beyond their reach. And maybe they have decided that silence is safer. There is also the possibility that the silence is a test. That somewhere out there, the watchers are listening to us as we listen for them, waiting to see if we will send something worth answering. Not just noise, not just a cry of existence, but a signal that says we are ready. Ready for what? We do not know. But if the quiet is a waiting room, then the only way out is to speak. And yet, there is a danger in speaking into a dark room. You cannot know who or what will answer. The silence between signals may not be empty, but filled with ears we cannot imagine, each one deciding whether our voice should be heard or erased. Perhaps that is why the others are silent. Perhaps they learned long ago that making noise in the wrong direction is the last mistake a species ever makes. Still, we listen. Still, we send our own small messages, mathematical sequences, pictograms of human form, the positions of our planets. We tell ourselves this is harmless, that space is too vast for anyone to notice. But space is not vast to those who can bend it. To them, our messages may be as loud and bright as a flare in the night. And if they have already heard us, if they have been watching us long before we learn to listen, then the quiet between signals is not about finding them. It is about waiting for them to decide what to do with us. In the end, the silence is not empty. It is a choice. And until we know who made it and why, every time we aim our instruments at the stars, we are not just searching. We are trespassing. We use the word God carelessly, attaching it to things we do not yet understand. Lightning, disease, the stars themselves. Once, each of these was a god to us. Then we learned their names, measured their patterns, tamed some, and endured others. But if there are beings in this universe 10 billion years older than us, the gulf between their knowledge and ours might be so vast that the only language left to describe them would be the language of divinity. Not gods of faith or myth, but gods of physics, entities for whom the laws of nature are tools, not limits. To them, the speed of light is not a universal ceiling, but a parameter that can be adjusted. The arrow of time is not a one-way path, but a river they can dam, divert, or reverse. Space itself is not a void to be crossed, but a medium to be sculpted, folded, and repurposed. We can barely manipulate a handful of atoms at once. We can trigger nuclear reactions, but only in crude bursts, burning fuel without elegance or precision. Imagine a mind that can rearrange matter on the scale of planets, changing their orbits with the same ease we shift furniture in a room. Imagine they can compress a star without collapse, reigniting its fusion centuries after its death, or cool a blazing sun to protect a nearby world from annihilation. To them, astrophysics would be an art form, but their reach would not stop at the macroscopic. The quantum realm, the strange, hidden structure beneath what we call reality, would be their playground. They could dictate the behavior of particles in ways we cannot yet dream of, alter the probabilities of events, force entanglements between systems light years apart, even seed regions of space with specific quantum states to ensure desired outcomes billions of years in the future. They would not just inhabit the universe, they would compose it. If such a civilization can do this, the distinction between technology and nature would vanish. To us, a galaxy spiraling into an immense black hole is a natural tragedy of gravity. To them, it could be a storage act, archiving stars as data points, black holes as libraries, each singularity a vault of compressed information more permanent than any artifact. We might see a supernova's flash and think it meaningless, when in truth it could be the equivalent of opening a communication channel, a deliberate, timed signal meant for someone who knows how to read it. The most frightening implication of this level of mastery is that it makes creation and destruction equally simple. If they can fine-tune constants, manipulate quantum fields, and shape the evolution of galaxies, they could make universes the way we make simulations. Not as abstract models, but as physical realities, complete with their own physics, timelines, and potential for life. They could nest worlds within worlds, hiding entire civilizations behind layers of space-time invisible to us. This raises a question that feels less like science and more like theology. If we live in such a construct, what does that make them? Not gods in the sense of morality or benevolence, but gods in the sense of authorship. They could decide the rules, adjust them on the fly, or even in the story. The familiar arguments about divine intervention, fate, and free will take on a new and unsettling dimension when the divine is a civilization older than the galaxies. And yet, what would such beings want? If they can create universes, alter timelines, and rewrite physical law, then our existence could be the product of deliberate choice or casual accident. We might be an experiment, a side project, a byproduct of something else they were doing. If they have the ability to spawn new realities, perhaps they do so constantly, filling a library of cosmoses where only a few are ever revisited. Ours might be an abandoned wing in their archive, still running, still alive, but never checked upon unless something unusual happens. But if they are watching, and all our suspicions suggest they might be, then perhaps something in us has caught their attention. Not our technology. That would be trivial to them. Not our intelligence. They would have seen intelligence rise and fall countless times. Perhaps it is our unpredictability, the way we act against our own apparent interest, the way we value things with no measurable utility, beauty, art, love, sacrifice. If they live in the precision of physics, maybe they watch us for the chaos. Or maybe they watch us for the same reason we watch ants. Not out of reverence, but curiosity. We move grains of sand. They move planets. We build tunnels. They sculpt galaxies. The gap between us and them is so great that the word equal becomes meaningless. And in that gap lies the terrifying truth. In the physics of godhood, morality is optional. To us, the ability to alter the universe comes with an implicit responsibility. To them, it may come with none at all. Some might hope that beings with such power would inevitably become benevolent, that with enough time, knowledge breeds compassion. But history suggests otherwise. Power, at every scale we've known, is neutral. Its morality depends entirely on the hand that wields it. And the hands of these ancient architects may have long since forgotten what it was like to be fragile. If they wished, they could erase us, not with violence or spectacle, but with a change so small we would not notice until it was complete, a slight adjustment in the chemistry of our atmosphere, a minor tweak in the sun's output, a subtle mutation in the DNA of a few key species. Our civilization could vanish not in war or disaster, but in a quiet fading, remembered by no one but the archivists who keep the records of dead worlds. Or they could elevate us. A change in a constant, a gift of energy, a reshaping of our planet's environment. And in centuries we could be unrecognizable to ourselves, a species leaping forward not by invention, but by design. If they can play with the laws of physics, they can accelerate or stall the trajectory of any intelligence they choose. We might already be the product of such interventions without realizing it. In the end, the physics of godhood is not about miracles. It is about the absence of boundaries. To such beings, there is no line between possible and impossible, no wall between what exists and what does not yet exist. They are not bound by the universe. They are co-authors of it. And in that light, the question is not whether they are real, but whether we could ever tell the difference between a reality without them and a reality they have shaped from the start. Perhaps we have never lived in a natural universe at all. We often imagine that the ultimate goal of a civilization is expansion, spreading into the galaxy, filling every niche, mastering every resource. In our own short history, we have projected this instinct outward, assuming that anything older and more advanced must inevitably follow the same path. But what if the opposite is true? What if the final step in the evolution of intelligence is not to dominate the universe, but to vanish from it? This is the possibility that unsettles more than any hostile alien armada. But the most powerful civilizations are not those we would see, but those we never could. Not because they lack the means to be noticed, but because they have chosen not to be. They are the ones who looked at the stars and decided that presence was a vulnerability, that visibility was an invitation, and that survival meant erasing every trace of themselves from the stage of the cosmos. In the early days of our search for extraterrestrial intelligence, we assumed that any advanced society would broadcast its existence the way we do. Radio waves spilling into space, light pollution blazing from their cities, engineering projects visible across star systems. But the more we looked, the more we realized that the silence might be deliberate. Energy is precious, even for a super civilization. Broadcasting without purpose is wasteful. And worse, it is risky. In a universe potentially filled with predators, to announce yourself is to gamble with your future. We know this instinct ourselves. In war, submarines run silent to avoid detection. Endangered tribes in remote forests avoid contact to protect themselves from disease and exploitation. In nature, countless species survive not by strength or aggression, but by camouflage. Why should the cosmos be any different? The ones who chose to disappear may have begun as empire builders. They may have explored, expanded, and engineered on scales we can barely imagine. But at some point, perhaps after an encounter with something more dangerous than themselves, they decided that the safest way to exist was to erase themselves from the map. Erasure at this scale would be nothing like the self-destruction we fear for ourselves. It would be meticulous, calculated, and complete. Their worlds could be dismantled, their structures broken down into debris indistinguishable from natural rock and dust. Their energy output could be masked to match the faint background glow of space. Their communications could be encrypted so thoroughly that, to an outsider, they would be indistinguishable from random noise. Over time, they could go further, altering the light of their own stars to remove signs of artificial interference, or relocating themselves entirely into regions of space cloaked from external observation. A civilization that has mastered space-time might even withdraw into a hidden pocket of reality, a separate fold in the cosmic fabric, invisible to anyone not already inside. If they exist in such a state, we would never know. To us, their systems would appear lifeless, their galaxies empty, their stars ordinary. We would search and find nothing but nature. And that is exactly what they would want. But disappearance may not be only about defense. It could also be about choice. Imagine existing for billions of years, having mastered every possible technology, explored every possible world, and learned every possible truth. Perhaps, at some point, the external universe becomes irrelevant. The true frontier might be inward. A civilization could turn away from physical expansion entirely, devoting itself to inner worlds of thought and simulation. Realities so rich and complex that the outer universe becomes nothing more than a faint background hum. If they can create entire universes within their own frameworks, why stay in this one at all? Why remain vulnerable to cosmic hazards, resource limitations, or hostile encounters, when they could live in perfect, self-contained realities of their own making? In such a scenario, disappearance is not retreat, it is ascension. And those who have ascended may watch us not with interest, but with a kind of nostalgic detachment, as one might glance at an old photograph from a forgotten youth. The great irony is that their absence could be the most convincing proof of their existence. In a universe that should, by sheer probability, be teeming with visible civilizations, the overwhelming emptiness may be telling us something. Not that life fails to survive, but that survival eventually means vanishing from view. And perhaps not all of them vanish willingly. Some disappear because they are forced to. There could be entities, older still, more patient still, that hunt, that consume, that eliminate competition before it can grow dangerous. The ones who chose to disappear may have done so because they learned this truth early, and because they understood the only way to survive was to make themselves unfindable. If this is the case, then our own trajectory is troubling. We are growing louder every year. Our signals, our lights, our machines. We think we are alone, so we behave like a species with nothing to fear. But if the cosmos is governed by a silent hierarchy, then our noise may already have been noticed. And in that case, our best hope may be to learn from the ones who vanished, before we, too, must decide between presence and disappearance. Perhaps they're not entirely gone. Perhaps their retreat is not total. In rare anomalies, in strange patterns of gravitational lensing, in unexplained energy shifts, we may be catching fleeting glimpses of their movements, faint ripples left behind by civilizations passing quietly into the dark. We dismiss these as errors, because the alternative is to consider that we are already living in a universe where the wisest survivors are those we can never see. And if that is true, then the night sky is not empty. It is crowded with absences, each one a ghost, each one a choice, each one a reminder that the ultimate power in a universe of watchers is not to be seen at all. We have always treated the sky as a truth. The stars above us feel like the one thing that cannot be forged or faked, the one view that has belonged equally to every human who has ever lived. Empires rise and fall, civilizations are born and vanish, but the constellations endure. The same patterns that guided ancient sailors still glitter above modern cities drowned in artificial light. We trust the night sky in a way we trust little else, because it feels too vast, too complex to be a lie. But what if it is? If an ancient civilization, 10 billion years older than ours, had the will and the means to control what younger species see, then our entire experience of the cosmos could be staged. Not with the crude tricks of illusion we know, but with a mastery of physics that allows the bending, blocking, and rewriting of light itself. They would not need to touch the stars to hide them. They would only need to control the paths their photons take. The principle is simple. Light travels through space along trajectories dictated by gravity, curvature, and the fabric of space-time itself. We have already learned to bend it in small ways, through lenses, mirrors, and gravitational lensing. But scale that knowledge up by 10 billion years of technological evolution, and the sky becomes a canvas. Entire sectors of the universe could be masked, replaced, rearranged, and we would have no way to tell the difference. It would not even require total coverage. Our view of the cosmos depends entirely on the light that reaches Earth. Intercept that light far enough from its source, alter it before it arrives, and you can give us any sky you wish. The arrangement of galaxies, the age of stars, the background radiation left over from the Big Bang. It could all be selectively edited to fit whatever story they wanted us to believe. And there are hints, subtle ones, that the sky we see might not be the whole truth. There are regions of space that are curiously empty, patches where galaxies are fewer or fainter than they should be. Astronomers call them voids, and most assume they're natural fluctuations in the distribution of matter. But the shapes of some voids are suspicious, too smooth, too sharply bounded, too coincidentally placed along our line of sight to certain phenomena. It is easy to dismiss this as coincidence. It is harder to shake the thought that we are looking at an edited file, not the original. Even the cosmic microwave background, the afterglow of the universe's birth, contains anomalies that resist easy explanation. A cold region here, an unexpected alignment there. We call them statistical oddities, brush them aside as quirks of measurement. But if you wanted to disguise the true nature of the universe, you would begin there at its oldest and most pervasive light. Change the first layer, and everything we build on top of it, our models, our predictions, our understanding, would be tilted just enough to keep us away from certain truths. Why would they do this? Perhaps to hide themselves. If they have chosen to disappear, as we suspect some have, then altering the visible universe is the most efficient way to prevent discovery. If you cannot see them, you cannot reach them. If their worlds do not appear in our sky, then to us, they do not exist. But there's another possibility, more unsettling. They may not be hiding themselves at all. They may be hiding something else, something older than them, something they do not want us or any young civilization to find. The sky could be a layered mask, not just protecting their existence, but concealing entire realms of reality from those not yet ready to confront them. In that case, the observable universe is not the universe. It is a projection, a curated model designed for us to study, to map, to think of as complete. We may believe we have charted the cosmos, but in truth, we have charted only the boundaries of the dome placed over us. Beyond that dome could be chaos or danger or simply the unknown, walled off until we prove ourselves worthy or dangerous enough to see it. And how would we prove ourselves? Not by technology alone. A species that could manipulate reality on this scale would not care about whether we can build rockets or split atoms. They would care about something deeper. How we use the knowledge we already have, how we treat each other, whether we can resist destroying ourselves long enough to pose a question worth answering. If the sky is indeed layered, then we're not living in an open world, but in an enclosure. Not a prison, but an experiment. The stars we see are the set pieces, the limits placed not by the universe itself, but by whoever controls the light. And every telescope we build, every deeper survey we conduct, is like a rat pushing against the walls of its maze. We think we are reaching farther, but we may only be pressing against the next layer of the illusion. There's a paradox here. If the Watchers wanted us ignorant, they could have given us a sky that told us nothing, chaotic, unreadable, without pattern. But instead, our sky is rich with structure and mystery. It invites questions. It rewards curiosity. It contains anomalies that, while subtle, persist long enough for the attentive to notice. It is almost as if the layers are meant to be peeled away, slowly, carefully, one at a time. Perhaps that is the true test, not whether we can build the tools to see beyond the mask, but whether we can interpret what we find without losing ourselves. Because the final layer, the one beyond which there is no more concealment, might hold something that rewrites everything we think we know, not only about the universe, but about why we are here at all. If there's a last layer of the sky, it is not just a barrier. It is a threshold, and like all thresholds, it demands a choice. To remain where we are, safe in the illusion, or to cross into a truth that may undo us. We began with the idea that we might be watched. We end with the possibility that watching is not a one-way act. That in seeking the Watchers, we have already placed ourselves within their gaze, and perhaps within their reflection. Because the more we search, the more the universe begins to feel like a mirror, one that doesn't just show us the stars, but shows us ourselves in ways we are not ready to see. When you stare into deep space, you are looking into the past. Light takes time to travel, and so the galaxies in our telescopes are ghosts of what they were billions of years ago. But if an ancient civilization is looking at us, they too see a ghost. Our primitive history, frozen in the light still on its way to them. The act of watching for both sides is an act of looking backward. We are mirrors to each other, never seeing the present, only a delayed echo. But a mirror can do more than reflect. It can distort. It can hide. It can be positioned so that you see only what someone wants you to see. If they have the ability to shape the light that reaches us, they can also shape the light that leaves us. Perhaps what they observe is not our true image, but a curated version of it, a version altered for reasons we cannot guess. In that case, they do not see us as we are. They see us as they have chosen to see us. And here lies the unnerving thought. What if the same is true in reverse? What if the sky we study is a reflection, not of the actual universe, but of the one we are allowed to see? Then both sides are trapped in each other's illusions, each staring into a mirror designed by the other. We tell ourselves that observation is harmless, that to watch is not to interfere. But in quantum mechanics, even the smallest act of measurement can alter the system being measured. The famous thought experiment of Schrödinger's cat rests on this idea, that the act of looking can decide the outcome. If this is true at the smallest scales, why should it not be true at the largest? What if the very act of being watched has shaped the path of our history, nudging us toward choices we never realized were being made for us? It would be easy to think of this as control, as manipulation, but perhaps it is something subtler. Perhaps the watchers are not sculpting our future in the sense of forcing it into a predetermined shape, but influencing it in the way a mirror influences the person who looks into it. We cannot help but react to our own reflection, adjusting, correcting, changing. If they can choose which version of ourselves we see, they can guide us without ever touching us. In this way, the mirror becomes a form of conversation. Not direct, not verbal, but a slow exchange of perceptions, questions, and choices stretched out over millennia. Each side sees something in the other, reacts to it, and in turn shapes what is seen next. And yet, one side may know far more about this exchange than the other. We must also consider the possibility that the mirror is not for us at all, that we are incidental reflections within a much larger design. Imagine an experiment in which many civilizations are watched at once, each seeing only the image meant for them, each enclosed within its own layer of illusion. In such a framework, contact is not forbidden, it is simply irrelevant. The true interaction is between the observers themselves, using the mirrored worlds as raw material for something we cannot comprehend. And what the image we see when we look inward? We think of the search for life beyond Earth as an outward quest, but in truth, every question we ask about them is also a question about ourselves. Could we survive for 10 billion years? Will we choose to expand or to hide? Would we shape the universe or retreat into our own creations? The answers are not hypothetical. They're already forming in the way we treat each other, in the way we use the tools we have now. We are becoming the kind of civilization we imagine them to be, whether we mean to or not. Perhaps that is the point of the mirror, not to reveal them to us, but to reveal us to ourselves. And in doing so, to test whether we are ready for the next layer of truth. If there is a final act in this cosmic exchange, it may not come as a message or a visitation. It may come as the quiet moment when the mirror changes, when the image we have always seen gives way to something unfamiliar, when the stars shift into a pattern we cannot explain, when the light from a galaxy carries information too precise to be natural, when a reflection speaks back, not in words, but in the language of physics, geometry, and time itself. We may not understand it at first. It may take decades, centuries, to even recognize that the change has occurred. But when we do, we will know that the watchers have decided we are worth addressing. And then we will have to answer, not just with our technology, but with our nature. The mirror that looks back is not a threat or a promise. It is an invitation, one that has been waiting for us since long before we existed, one that will wait long after we are gone if we fail to see it. And so we keep looking, knowing that in doing so, we are also being seen. Every photon we capture, every signal we send, every pattern we notice is part of a conversation we do not fully understand. The night sky is not just a map. It is not just a memory. It is a face, patient, inscrutable, ancient, meeting our gaze with its own. We began as children staring into the dark, wondering who might be there. We end with the realization that the dark has always been staring back. And somewhere, in the infinite reflection between us, the next move is already being made.